Hi, this is part 2 of a series of videos where we're dealing with air quality control, carbon monoxide alarms and all that kind of stuff. And as we saw, there is a range of these cheap sensors over here. They all start with MQ, 2, 3, 4, 5, 6, 7, 8, 9 and 135 and so on. Last time we tested a 135 sensor, which is what we've got here. And that's a general purpose sensor that senses all sorts of things in the air, from carbon dioxide to alcohol and all sorts of stuff. So you can actually get a reading of that to measure the air quality in general. Then I have the MQ09, which I'm actually using on a little test rig right now. And last time we also used that to burn it in as well. Now this guy here can actually sense carbon monoxide as well as like gases, like from gas stoves and so on. This one here, however, is more tuned for just carbon monoxide. So that is actually what we want if we want to build a carbon monoxide alarm. This thing over here, this is the lid of the one that actually stopped working after 10 years. It refused to keep working, even though it still seemed to work. But there is a cutoff there. You had to buy a new one. So I thought by myself, well, I wonder if I can actually make one with one of these sensors. And originally I had in mind to use a small microcontroller, like an 80Tiny 84 or something like that. But I've actually come to realize, I did a little bit of research on these things over here, and you see they have a little graph. They vary over humidity, 33%, 85%, slightly different, and over temperature. But what I've actually found is that the variation actually is fairly minor, and I realize I'm not actually interested exactly in the parts per million that I'm reading, because this thing actually is burning in right now. As you can see, it's had 46 hours. You're supposed to burn them in for 48 hours before they become accurate. And so there's just a couple more hours to go. And this is why I've plugged it into here. So, but all of these devices, they have, as we discussed last time, and I showed the circuit, they have an adjustment on there, a little trim pot over here, and a comparator. And the output voltage from this sensor is actually fed into the comparator, and plus the voltage that is generated by this resistor, and it gets compared, and then at some sort of threshold it'll trigger, and the D0 output is over here, will actually go low, active low, and you can actually adjust that level with this little trim pot. So in actual fact, all I need to do is to actually, as you can see in clean air right now, I got 1.45 parts per million. And what I need to do is to actually adjust this thing so that it's just off from the trigger position. So if any increase in carbon monoxide happens, which would be out of the ordinary, it will set an alarm. It doesn't have to be at 50 parts per million, which is the recommended maximum level by OSHA or something like that. So that doesn't matter. All we need to do is to trigger it if it is, maybe 3 or something like that on that scale, because obviously if the carbon monoxide is up, something needs to be checked. So that's all we need to know. So anyway, to make a long story short, so this, for interest sake, this guy is running on a different library now to run this MQ09. I found a library that can run all of those things, which is different from the one that we used last time. Last time we used a specific library that was just for the MQ 135, which is good because it had the adjustments for temperature and humidity already built in. But this one over here is called MQ Unified Sensor by Miguel Khalifa, and it can handle all of the 2, 3, 4, 5, 6, 7, 8, 9, 131, 135, 303A, and 309A. So that's pretty much the whole family. So I've got this currently set up in the code in order to actually do the MQ07. So you define the MQ07 sensor there, that's how you do it. And of course, this one allowed for the ESP32, so we got 12-bit A to D converter and stuff like that. So that's what we're running, but we won't be using this for our final version. For our final version, we don't need a microcontroller at all. That's the theory anyway. And I have made up a little circuit there that looks like this. So I am proposing to, I'm going to put a little socket on a little board so that the sensor, the MQ7 sensor in this case, can actually be unplugged and replaced with a different one or whatever. So I would rather not solder it onto anything. I'll put a little socket, and we are using the D0 output. As I said, that's active low, and that's actually coming in this NAND gate over here. We're using a 4011 chip, which is an old-fashioned CMOS logic chip, and it has 4 NAND gates in it. So we're using one NAND gate actually as an inverter. We got the inputs connected together. We feed D0 in there, so it becomes active high now as it comes out because it's inverting it. And we then enabling the output to the buzzer, which is all it needs is a voltage, which is connected over here. And these 2 NAND gates we're actually using as a low frequency oscillator. We are wanting oscillations of maybe 2 or 3 times a second or something like that. And what it actually does is it cuts the buzzer in and out, because otherwise this kind of buzzer that we're using is an active buzzer, and it will stay on as long as it's got voltage, so it continuously beeps, and we want it to go beep, 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 or something like that, you know. So that's what the purpose of that is. And I have found an old power supply plug, you know, wall wart thing that I'm not using anywhere, from a device that is failed or been disposed of or whatever. So I am using a 7805 type of regulator here, linear regulator, a couple of capacitors to output 5 volts, because the actual sensor needs 5 volts. But the actual buzzer likes more voltage, so I'm applying, actually it's 8.5 volts roughly. I'm applying that to the buzzer there. So that's the circuit. Is fairly simple, and to look at it, I've got the little test circuit over here. Down a bit here. Okay, as I said, this is happens to be an active buzzer. If you've got a passive buzzer, which actually the more common ones, you can only really use it with a microcontroller, and typically in Arduino you use the tone and no tone commands to actually, and you give it a frequency to actually make the buzzer work. But because we got no microcontroller here, we want to use this active buzzer. This thing is actually rated for 3 to 24 volts, and the more voltage you give, the louder it is, of course. I find that at 5 volts it was a little bit softer than I liked, so that's why we're giving like 8.5 volts, which is going to come in through here, through this little barrel jack. And this is the regulator with these 2 little capacitors. Here is the capacitor and resistor for the oscillator. This is the 4011 chip. And we are using an MQ9 sensor right now for testing because it behaves pretty much exactly the same as the MQ7 with respect that when it triggers. So if I plug it in, so as I said, I found, let me untangle some wires here. I found this little wall thing, which is actually rated at 7.5 volts, but it actually outputs 8.5 volts. It's not regulated, in fact. You can tell from that. So that is, I'll plug it in and give it some voltage. Now, until the heater heats up, this thing tends to trigger. That's what you hear, and you can see that the buzzer is beeping, and so we know our little oscillator here is working. The voltage is coming in, and I've got a little adjustment tool here, so I'll temporarily adjust it out. That is off, and I just so you can just set it so it is just off in actual fact. And if I now take a match and light it and hold it near it, you will see it will go off. There it goes. Put it away. So it is quite sensitive. That little tiny bit of carbon monoxide that obviously comes from a yellow flame is enough to trigger it. And of course I can make it higher if I find that I don't want it to trigger on very small amounts, but that's something I can do later to adjust. In any case, this is the circuit and it's working, so that's what we're going to be using. Let me unplug it here. Alright, so this is the actual little box that is actually part of the old commercial carbon monoxide alarm. I've made a hole there, and the plan is to have, this is the beeper. I'll put the beeper in there with some sealant around it, and the actual sensor I'm going to put in here. But because, as you can see, when you first plug it in, it'll beep for a little while until the heater actually comes on. I put a little switch on here, which I'm planning to put in line with the beeper so that you won't be able to hear it while it is warming up. And it only takes like, a minute or a couple of minutes. And this thing would be plugged in permanently 24 hours a day, so it's just there for convenience to get it going. Alright, so this is how it's going to be inside. I made up a little some wires here to plug into the board over here. And these wires there, I'm going to trim them off, of course. They're going to be soldered onto a little board. I've made up a little perf board over here that's going to fit in there. And these components over here are going to go on there. So I guess we can start doing that now, because we have discussed everything that we need to know, I believe. So let's go and I'll get set up for that, and that's what we will do next. Okay, so let's get started. So I've done a few little things off camera to prepare already, otherwise video gets too long. So what I've decided to do actually is, this is the module here, it's being burnt in for 48 hours. I have actually mounted a potentiometer at the bottom here and a switch, and the plan is that I want to be able to switch out, and I put a little socket on this beeper over here, that I will be able to plug into the board. I want to be able to remove the board and everything, so I'm going to use, since this is still kind of experimental, I want to be able to disconnect everything and remove it without any problem. So I don't want any wires soldered permanently to devices and so on. Anyway, so I made up a little cable here that plugs into the pins on the potentiometer. This one we are going to solder a wire to, but then the wires from there to the board will be going to a socket, which is going to be like that. All right, so now this potentiometer is going to take the place of this little adjustment over here. I have already desoldered it, so I guess I could have done it on camera, so I'll talk about that. So what I did was I used one of these. I didn't want to use, the pins were coming through here, I didn't want to use hot air because this is plastic, so I just used this blade over here when I could touch all 3 pins at the same time, and then it just fell out. However, this is they're very small holes, and I then used some solder wick to wick the solder out as much as I could, but it doesn't all come out. And that's where these little tools come in. I never see anyone use these on other YouTube channels. I guess they're just trying to do things for entertainment, trying to click on it and stuff. But practically speaking, you've got these little tools over here. They are actually desoldering tools, and the narrowest one is actually the one I use the most. And unfortunately, when they made these things, the plastic handles are actually not heat proof, so if you heat the needle too much, it'll come out. That's why I put some heavy duty epoxy on the end of it here, that'll actually is more heat proof and it holds it in. In any case, these things are cheap and you can find them on the internet and AliExpress and so on. So what you do is you heat up the little holes, and then you can just, this is stainless steel, so solder does not stick to it, and you can just push them through and that'll clear out the holes. So that is what you do in order to prepare this for holding. In our case, we're going to solder wires into there, and well, it'll be the wires coming from that potentiometer here. So I can temporarily unplug those. You see I put pins on there as well. These are actually pins like DB9 pins, you used to have on serial connectors and so on. They were suitable, and the little female parts I put in here and put some heat shrink tubing over the top of it, so it makes entrance little plugs. And we can solder these in anytime, any way we like. But the middle one's going to be green. It's going to go to that middle socket over there, because that is how these things work. The middle pin over there is always the one that is that varies, and the outside pins you put voltage and ground on and so on. Okay, so let me strip off these little bits of the wire here. I've got 2 different kinds of solder here. This is El Cheapo Chinese solder, and it's not very good, but it'll be good enough to solder the stuff on this little board with. But this is good solder. It's actually very old solder. I used to live in Australia for 20 years, and there used to be a place called Dick Smith's, and they sold electronic stuff. They were competing with Radio Shack or Tandy at the time, but they're all defunct now. Okay, so I'm going to use my 50-watt Etten iron for this, because they are very small pads, and I like using a small iron for those kind of things because they'll be less likely for damage. to this PCB. I think this wire is kind of old wire that I've recycled, and I think a little bit of flux here is not going to go astray. And I'll put a little bit on the other holes too when we're ready, because I see that it is not taking as well as I would like it to. Okay, that will do it. Very good. Now the wire doesn't slip out, so now I can do the other two. Clean off some of that flux there. Okay, so we've got that prepared. Put that aside. Now on this thing here, this is going to be the power input, and I have already measured. I made one of those little things red, so that reminds me that that is positive. And I'm going to put that little socket on there, so I can disconnect it from the board, because these things are a bit of a trap. You see how they poke through there and they screwed in. Once you solder that to the board, you can't take them out anymore and disconnect them unless you put a socket on there. You'd have to unsolder the wires. And because, as I said, this is still sort of experimental, I want to be able to remove everything and maybe make changes or whatever if needed. Okay, let's solder that one on first. Yeah, that's one. That's that done. I had to snip a little bit of this. There used to be batteries in there which we're not using, so I made some more room by removing some of that. Okay, so let's have a look now. Here, this is the beeper. It's going to go there, and one of those wires, it'll be the black one, we're going to solder to this switch over here, and the other one goes there so that we can cut off the beeper when we want to. I'm going to use different strippers for those because I want to just can actually plug this back in. And this little board is going to be mounted over here. I'm going to use some of that foam double-sided tape, I think. And this here, I'm going to go on there, and that will be soldered to the little board. But we got to prepare the board now. What I tend to do is I've got the circuit over here, and I will highlight the connections that I have already made so that I won't forget any, because it's easy to do. So first thing to do is this is input, this is ground, and that's output. And I got on the input I have this little electrolytic capacitor, and the output is this little green cap thing here. So I have bent the pins down here. I'm going to use this flux over here, which is just ordinary rosin flux, because some of these components I've had for many years. They're probably 30 or 40 years old, and they have some corrosion on there, and that is what you use rosin flux for. The kind of flux that you use on PCBs that you see people use, they actually have a different purpose. They will not remove corrosion. Alright, so we have this done, we have that done, and we have that done, and we have this done, and that done. So this section is complete. Now let's have a look. Could put just a little bit of wire across those underneath, but I prefer to do it this way so I can see where they are. And we've got 12 and 13 being connected together. Is A0 we're not using, D0 is the end, so that's the blue wire. It's going to go to pin 12 and 13. So that's the two that are connected together. So they can go in here. Yeah, looks good. All right, so now we have the power stuff to do. We need ground, which is going to be the brown wire here. So I think what we will do, if I'm not mistaken, okay, so gun is heated up, and what I do is I put some hot glue right over top of these wires here where they are joined to the board. That is provides strain relief, and I'm going to do them over here for these wires as well. That should do it. Off camera I also put a little bit of hot glue over there. It's another one. You should be able to plug this in. Oh, this stuff is so sticky. Okay, everything is mounted. This little plug should be able to be plugged in here. That you can plug the power in. I'm not going to mount this little board yet. I'll put some double-sided tape on the bottom of it for now, and it's going to go in here, but I'm not mounting it yet until we have been able to test it. Okay, the hot glue gun can go off, and we plug in the power again. Okay. A little red light came on, that's a good sign. That switch is working to switch the beeper on and off. Turn the light off there. Yeah, you can kind of see the little LEDs. You can kind of see the little LEDs glowing through there. That's good. There's little plastic things next to it. They transport the... Well, I think everything is working, so we can actually mount the little board then. Let me get the backing of the tape. Oh, I think I wanted to mount it this way, didn't I? Yeah, that's better. Okay, push that in. Route some of these wires around. Some glue there. Okay, put the little backing plate on that mounts to the wall. Oh, it goes this way, I think, yeah. Alright. Well, I think that is it. I will mount it and try it out over time. And I'll adjust this just so it stops beeping after it's warmed up. And I think that's it. I think that was a successful little build. I think that there is... There we go. That's how it's supposed to go. All right. Okay. Well, I think that's it. This is a fairly simple circuit and it does the job. I collected some old parts from my bin, but just for the little sensors, are like they are less than $1 each, and one little chip and a little potentiometer, a couple of dollars worth of components there. Most of them I recycled anyway, so saves me $20 to buy a new one of these things. And I guess that's it, and I'll see you guys later. If you like this sort of thing, don't forget to like and subscribe, and I will see you later. Bye bye.